So in this video, we're going to go over chapter 2.2, which is graphs of functions. If f is a function with domain A, then the graph of f is a set of ordered pairs, x such that f of x, and then x such that x is an A. So this is our ordered pair, x, fx, where our fx is really the y. So these are plotted in the coordinate plane. The graph of f is a set of all points, x and y, such that y equals f of x. So the graph of f is represented by the equation y equals f of x. So f of x equals mx plus b is a linear function. Fx equals b is a constant function. Fx equals xn, those are power functions. And then fx equals x to the 1 over n is a root function. So here's an example where we're going to graph this function by plotting points. So our f of x equals x squared. So these are our various values of x. So we have 0, plus or minus 1/2, 1, 2, 3, and then it doesn't matter if they're positive or negative because when we square them, they end up being positive. So we plot our points. So we have our various plotted points here. And that one, 0, 0, 1/2 to 1/4, -1/2 to 1/4, 1, 1, and then 2, 4, 1, 2, 3, 4, and then 3 to the 9th, all the way over there. Okay, and then b, we have gx equals x cubed. So we make our table of values. We have 0, 0, 1/2, 1/8, 1, 2, -1/2, -1, -2, -8. So we have 0, 0, 1/2 to the 1/8, 1, 2, 2, -1/2 to the -1, and then -2, -8. Alright. Then we have hx equals square root x. So we have our table of values. We have 0 goes to 0, 1 goes to 1, 2 goes to square root 2, 3 goes to square root 3, 4 goes to 2, 5 goes to square root 5. So these here are pretty common functions, are x squared, x cubed, and square root of x. So it'd be good to memorize the shape of these functions. Okay. So graphing piecewise defined functions. So a function defined by different formulas on different parts of its domain are what's called piecewise. So in previous videos, we've seen piecewise functions, we've evaluated them, but now we're going to graph them. So we want to sketch x squared if x is less than or equal to 1, and 2x plus 1 if x is greater than 1. So this side is our fx equals x squared if x is less than or equal to 1. So we're going to have a parabola when x is less than or equal to 1. So these are the values of x going this direction. So we're like, okay, we're less than or equal to 1, less than or equal to 1, we're equal to 1, so we have dot, then we stop. And then we start at 2x plus 1, which is all the way up here for 1, and that's if x is greater than 1, so that's why we have the open dot. Okay, so greatest integer function. So when you have x with like the double brackets, that means greatest integer, which means less than or equal to x. So it's like a rounding function where you're rounding to the nearest whole number. So, but it has to be less than or equal to it, but not greater than or equal to it. So you're not rounding up, you're like rounding down basically. So the greatest integer of 2 is less than or equal to 2. And then 2.3, we want something that's less than or equal to it, but that's a whole integer. So 2. 1.999, we want a number that's less than or equal to it. So 1 is the the greatest integer that's less than or equal to 1.99. So we're rounding down. So when we graph it, it actually looks like a step function. So our value of -2 when x is between -2 and -1, that's going to be -2. So we have from -2 to -1, we stay constant and we stay at -2. And then it doesn't include -1, so that's why we have a hole here and then a dot here for when it's equal to. So those are like, all of them are going to have that form where they have the close and then the open dot. So for example, when we have 0, any value of x that is between 0 and 1, we're going to round down to 0. So that's why it's going to be there. Any value between 3 and 2, so say we had 2.5. The greatest integer that's less than or equal to 2.5 is 2. So that's why it would be 2. So that's a step function. So a function is continuous if the graph has no breaks or holes. So for example, the piecewise and the greatest integer function, these aren't continuous because this is a break. We have some breaks here. We have a hole. We have a lot of holes in that one. So those ones aren't continuous. But like our parabola, x cubed, these are continuous. They don't have any breaks. If you could follow the function and then fall off, then that's a break. So our vertical line test. A curve in the coordinate plane is the graph of a function if and only if no vertical line intersects the curve more than once. So if each vertical line x equals a intersects a curve only once at AB, then exactly one functional value is defined by f of a, and that's b. But if a line x equals a intersects a line twice, say at AB and AC, then it can't be a function because a function can't assign two different values to a. So here's different applications of the vertical line test. So if we did vertical lines, so this one passes. This one does not pass because it touches it twice, 3 times. So that one is not a function. This one, it touches it once, twice, so this one's not a function. This one just touches it once, so it's good. This one also touches it once, so we're good. All right, here we want to see, does the equation define y as a function of x? So we have y minus x squared equals 2. So we're going to get y by itself. So we have y equals x squared plus 2. Yep, this is a function because it gives one value of y for each x. Let's try x squared plus y squared equals 4. So we get the y by itself. We have y equals plus or minus 4 minus x squared. So this isn't a function because it gives two values of y for a given x. Say we had an x of 1. So y would be plus or minus 3 for x equals 1. So it's not a function because there's two different values of y for x. Okay, so these are just various different functions that are pretty good to know and be familiar with, even to memorize. They're pretty common. So we have our linear functions, our y equals mx plus b. This one's the constant function. This one's a linear one. We have our power functions. So we have a parabola, our quadratic x squared, x cubed, x4, and x to the 5th. Notice how for like the power functions, the even powers, they look pretty similar. And then the odd powers look similar also. For the odd powers, we're getting flatter at the origin, the greater the power. We have our root function. Also, we have the square root x, cube root x, 4th root x, and then 5th root x. So notice again how the even powers are similar and then the odd powers also are. And then we have the reciprocal. We have 1 over x, 1 over x squared, 1 over x cubed, 1 over x fourth. Again, the even powers are pretty similar and the odd powers are. And then we have our absolute value function. Okay, I'm going to go ahead and stop the video here. We'll continue with 2.3 in the next video. See you then.